So let's look at how we classify IPv4 addresses. So there are 5 main classifications from A down to E. E is reserved for research. D is a special type of address which defines a multicast. With multicast, we have a single address that we can send data to, and then all the subscribers who are registered to that address will then receive the data. So it's not like broadcast, where broadcast sends to everyone on the network. Multicast is only sent to those subscribers who have registered to be able to read from that address. The 3 main IP address classifications that we have are A, B and C. With A, addresses with a 0, A addresses start with a 0 in the most significant bit of the first octet of the address. So we have 24 bits, and this is segmented into 4 octets. So for the first byte, if it's a 0, then we have a class A, and the next 7 bits determines the network part. After this, we have 24 bits for the host part. So for the addresses that we can have all zeros and a 1 here, which will give us this address, and then the maximum address would be all 1s here, or 127, and then all 1s for the hosts part. Default subnet mask we have is 255.0.0 for class A, so that's this part is network, and all this part is the host. So we can have a maximum number of 126 networks because all zeros is reserved for the network address and all 1s are reserved for the broadcast address. So for the maximum number, so this is 2 to the power of 7 minus 2 gives us this, and then 2 to the power of 24 minus 2, if we don't include the network address or the broadcast, gives us this amount of hosts on each network. Class B starts with 1 and then a 0. So then the next 6 bits here and then 8 or 14 bits defines the network part, and then after this the next 16 bits defines the host on each of these networks. So if we put in all zeros here, then we'll get 1 to 8. If we put in all 1s here, then we get 192. So the maximum number of networks that we can have is 2 to the power of 14 minus 2. The maximum number of hosts on each network, if we exclude the network address and the broadcast, then it's 65,534. 2 to the power of 16 minus 2. Next we have a class C. With a class C we have a lot of network addresses to allocate. So we have 21 bits here for the network part and only 8 bits for the host part. So to fill these all in with zeros, then we'd start from 192, and if we filled them all with 1s, we'd get 223. So the default subnet mask is this, and then the maximum number of networks is 2 to the power of 8, 16, 17, 18, 19, 20, 21, 2 to the power of 21 minus 2. Maximum number of hosts, if we exclude the broadcast and the network address, is 2 to the power of 8 minus 2, which is 254. Okay, so let's look at some examples. Okay, so we'll do this test here. So we can see here 137. 137 fits into this range, so we have a class B address. And we have 113. So let's look at our address ranges again. So 113 is a class A. 189. 189 fits into a class B. 105 is a class A because it's between 1 and 127. 41 is a class A. Okay, so we got 5 correct there. So that explains class A, B, C, D and E addresses.